All right. Howdy, everyone. Welcome to the Autonomous Systems Showcase presented by Deep Tech Showcase. Really excited to have everyone joining. I know there's a lot of familiar faces and some new faces. So welcome everyone. Excited to get this show on the road here. Today's agenda is it's not going to be a particularly long showcase, but right now we're doing the opening remarks, and then we're going to have one session and then another session. There's no difference between the two sessions. It's basically just different companies presenting in each session. So there's no specific focus area. Rather, it's just different companies. What's our goal? What are we doing here? Our goal is to get more deep tech or innovation or bleeding edge technologies to market by leveraging the community that we've built out. What we've seen a lot of the times, and it's painful to watch, is that someone can come out with, some really good innovation, and then when it comes to actually, implementing it or getting it perfect, it's hard, and it's also hard to have it, to sell it, right? To not rather than it just being in the lab, to actually get it to a point where it's, commercially ready is difficult. So our goal is to try to connect and ease that pain. Not a perfect one-stop shop. That being said, there are definitely areas that we have helped with and are looking to help with wherever we possibly can. One of those being using this ecosystem that we made to connect startups with tech scouts from both government and corporations with investors. And so the two main activities we're doing usually is showcase events like today. Basically, what we do is we have a lineup of companies, about 5 to 6-ish companies per session. And then during those times, they get 5 minutes to pitch, followed by 5 minutes of Q&A. And the Q&A is done by the panel. Just a note on that, because I could get ahead of it now. For everyone on the panel, if you would like to ask a question, there's a little reaction tab on your Zoom bar on the top or bottom or side of your screen. And if you want to raise your hand and ask a question of the company, feel free. If you can't find the hand raise button, that's fine too. Simply just, blur it out. We'll try to accommodate and get to everyone. That being said, two-part questions or very, very long questions we might have to cut off, but, do it and then we'll figure it out as we go. Don't be shy. The second piece is guided introduction. So for anyone on this call, if you see a company, you like the company, you want to connect with the company, let us know. We really like to foster connections, and that's the whole goal of this shindig. So if you see something that's interesting, feel free to reach out or feel free to talk to them. They're also going to leave their emails in the chat after their presentations. Our next two showcases are the Space Showcase and Future of Computing. So stay tuned for that. And with that, I'm going to let my colleague, David Fertig, tell us a little bit about our sister company or parent company called Eagle Point Funding.
Hey, thanks for that, Asher. So first of all, nice to see everyone. Nice to meet everyone. Just to piggyback off of what you were saying, obviously, in addition to all of the amazing things that the Deep Tech Showcase does, Eagle Point Funding is our attempt to actually be that one-stop shop for anything B2G, business to government, that you might need. So in addition to all of the connections and showcase events and everything else that Deep Tech Showcase has going on, we have another department within Eagle Point Funding that their job is to help you basically submit formal proposals to various different government programs. So it could be anywhere from early stage R&D if you're interested in SBIRs, or it could be other broad agency announcements or OTAs, really anything under the sun, as long as it's federal government for technology, and as well as helping you move along into the later stages, getting into government procurement contracts, actually doing business with, on a sole source basis with various different agencies. And that's, of course, where a huge portion of the Deep Tech Showcases work really starts to come to fruition, because you need all those connections. So I'll let everyone get back to the show, and I won't take up too much more of your time. But if anything I said sounds interesting, please feel free to scan the QR code. I'm also going to drop my calendar link in the chat. Actually, it looks like now I do have access to send to everyone. I'll drop that in there in a minute or so, and thank you very much. I'll hand it back to you.
Absolutely. Thank you, David. And feel free to, don't be shy. I book calls with him all the time. I like to talk to him. So
That is actually true.
All right, to quickly run through the agenda of this showcase, we're gonna first start off with Macrove. I think I see Matt here, all getting queued up. You have a few more minutes, don't worry. Followed by that, we're gonna have Xenodrone, Target Arm, Cognosy, and then for session two, we're gonna have RightNet, Skyfish, Dolphin Labs, Swarmbotics, and then a farewell, which won't be. I don't think it's going to be as long as set out in the agenda, but we'll see. Anything could happen. With that, what I'd like to do is I'd like to quickly go around. Not so quickly. You guys can take your time, but go around the panel, talk a little bit about who you are, what you're looking to see, what area of autonomy you think is going to see the most advancement in the coming months, years, because I know there's a lot going on, and I feel like we're on the cusp of a whole explosion of tech, especially in this area. So I'd love to hear that. So with that, we're gonna have Jim Rutt go first. Just tell us a little bit about yourself and what you think is going to be interesting in the autonomy space going forward.
Well, I don't know what's going to be interesting, but I can certainly give you my background. That'd be a lot
Sure,
easier. Yeah, so
sure, go for
I'm
it.
the CIO and CISO of the Dana Foundation in New York City. I'm also a venture partner at 645 Ventures in New York. We're a B2B fund. We're fourth fund, 347 million. So I also do a bunch of direct advisory for startups. Have in the past and done a number of angel investing as well as micro VC funding. So autonomy, God, you kind of got me, Asher. I don't really know off the top of my head. It's one of those questions that I can answer after I've kind of refreshed myself as a result of this panel. So I'll
Go
leave it
for it.
there.
Absolutely, absolutely, all good. All right, perfect. Thank you for joining us, Jim. Next up, we have John Dickerson.
Hi, I'm John Dickerson. I'm from the Phoenix Spark Innovation Lab. Can you guys hear me?
Yep, loud and clear.
Oh, great. What we do here at Travis, it's at Travis Air Force Base. We help bring innovations to the warfighter here on Travis and in the Air Force at large. What we're looking for automation is just automating the force. That's the new thing now with more drone technologies and AI incoming. And what I'm looking for is just innovative companies that will fit a better fold into what we do here at Travis.
Absolutely, absolutely. It's a pleasure to have you.
Thank you.
Next up, we have Marissa McGinnis.
Hi, good morning. I'm an investor in Silicon Valley, and I'm interested in drones, robots, and space. And currently, I'm trying to buy some SpaceX stock. So if anyone knows anyone selling, I'd appreciate you connecting me. Thank you.
Absolutely, absolutely. It's a pleasure to have you. Next up, we're going to have Mike Telside.
Hey, good morning, everyone. Mike Delside here from the Spaceport. I'm currently the Deputy Branch Chief for Mission Protection for space sensing. Today, I'm just here to hear the pitch and learn more about the companies, seeing what's going on and how I can help them. I'm also involved in numerous accelerators as mentors. So what's next for in terms of technology? I think robotics, especially in manufacturing, will be very hard in the future. Happy to be here.
Absolutely, it's a pleasure to have you. Next up, we have Bill Waynick.
Hey everybody, Bill Waynick. I'm on a government laptop, so I have no camera, but I am the senior advisor for warfighter communications over at the headquarters Air Force A6 and stationed at Davis-Monthan, but still assigned to the Pentagon A6 folks. I'm looking for anything connectivity, send RF, send zeros and ones, laser, like fiber, MANA, whatever waveforms are out there. Primarily looking at that for helping us with some resilience in communications. Over.
Absolutely. Pleasure to have you here, Bill. All right. Next up, we're gonna have Gopal.
Hey everyone, my name is Gopal Rajaraman, investor with Lockheed Martin Ventures, which is the investing arm for Lockheed. We invest broadly across 14 different areas, including autonomy. I look at autonomous systems and AI investments for Lockheed. Nice to be on the panel.
Absolutely. It's a pleasure to have you, Gopal. Next up, we're gonna have Anthony Macera. Anthony. All right. I guess we'll come back around to him when he's ready. All right. Sarah, you want to quickly introduce yourself?
Sure, yes. My name is Sarah Scharf. I am with BAE Systems. We do not have a venture arm, so we don't do any direct investing. However, we do work with startups through partnerships and collaborations. I'm one of the technology scouts for that. And we mostly are scouting for technology for our R&D group, which we call Fast Labs. And some of the different focus areas of our Fast Labs is AI, ML, autonomy. We also do sensing solutions, RF, EW, microelectronics, anything electronic systems related. BAE as a whole does a lot more than that. And so sometimes we'll refer people on beyond that, but that's mostly the focus areas that we're looking for. Thanks.
Pleasure to have you, Sarah. Absolutely. So next up, we have Joe Epstein.
Hi, everyone. My name is Joe Epstein. I'm the strategic partnership lead for Lockheed Martin Space. Unlike Gopal, I'm looking at technology at the component level, where Gopal is looking at much more at the company level. What I'm looking for, again, like everyone else said, autonomy can be a broad-based topic, but really what we're looking at is how are autonomous systems going to operate in spacecraft operations. So that means performing on space-rated processing and computing. First of all, being able to operate on rad-hard situations, but also in their autonomous operations, whether that be robotics or RPOD, just to name a few of the different ConOps that we're looking for. And I really want to hear, like what everyone else is probably wanting to hear, kind of what sets you different than everyone else. The technology is moving so fast. It's very hard for many of us to keep up what is actually better or what is a discriminator. So, how do you differentiate yourself from your industry peers? Thank you.
Sure. Absolutely. Thank you, Joe. Next up, Rachel, I know you may have just joined, so in case you did not hear, we're quickly introducing ourselves and saying what area we're interested in. If you want to quickly say hello.
Hi, let me know if you could hear me.
We can hear you.
Okay, perfect. Hi, I'm Captain Rachel Marin. I'm over at Dover Air Force Base. I'm the project manager of virtual and processing. So a lot of like software companies and software projects I like to work with. I was in a maintenance unit for 2.5 years. So if you have anything that maintenance can use, specifically Backshop, we have some connections there. I also worked with Phoenix Spark Innovation Cell. So I am specifically excited about just seeing autonomous solutions and how we could hopefully save the Air Force time and resources to get back to the mission.
Absolutely. Perfect. Pleasure to have you, Rachel. Anthony, if you want to give, I see that you're back on the chat. If you want to say hello, quickly introduce yourself, you can. Oh, there you are.
Yes. Yeah, I lost connectivity. I'm not sure what happened. Anyway, Anthony Macera, Air Force Research Laboratories Information Director here in Rome, New York. We look at things of cyber assurance mainly, but for automation, it's very interesting. What's up and coming in automation, I think, in my mind, is the generative AI that's moving right along here. And we are interested from a perspective of, with automation, how do you secure the software and hardware in these automated systems? Looking forward to the conversation.
Sure. Absolutely. Pleasure to have you. All right. With that, I think we covered everyone. If not, I apologize in advance. And happy to, quickly do an introduction while we're going through the questions and et cetera, et cetera, if I missed anyone. with that, I'll give the floor over to Macrove, and presenting for Macrove will be Matt. So Matt, go ahead whenever you're ready.
All right. Hey everyone, I'm Matt Lubinsky, Director of Business Development at Macrove. Is my screen showing?
Yep.
Okay, cool. So a little bit about us to start. We've been in the manufacturing space for close to 40 years now. The bread and butter of that was basically installing material handling systems into big facilities like Amazon's and FedEx's. So that's like your traditional conveyor belts and racking and sorters. And in the past 3 years, what we've decided to do is kind of shift that focus and design and build these robotic material handling systems where, hey, we take these original processes you would find in a warehouse and replace them with robots. So we were recently awarded our phase 1 SBIR contract and working with Joint Base Charleston on our phase 2. So this has both a commercial and defense application to it. So we don't actually manufacture any robots. We have about a dozen partners that we can kind of pick and choose from, depending on the use case that our customer needs. And what we do is we really go into a conversation with the customer and find out what pain points they have in their facility processes. Are they trying to automate certain processes? Are they, short-staffed in certain areas? And we custom design systems basically to help solve those problems. In the video you see here, these are actually systems that we design and build kind of as examples. But what we're really doing is kind of taking your traditional process of a warehouse of storing materials, moving them around a facility, picking and kitting them, and having that whole process be used strictly with robots. So we did build our own proprietary software that runs the whole system. It's kind of the brain of all of these robots working together, putting in the orders, collecting the queue. And we actually use machine learning to help optimize the system as it is used in a facility. So if there's a bin that's maybe in the way back of the facility, and that one's being chosen a lot to be picked and kitted, the robots and the software actually know, okay, I should actually move this bin closer to the picking and kitting area. So it kind of speeds up that process of picking and kitting materials. We also do kind of a lot of storage-based systems, basically robots just moving bins to and from the facility. And again, all of these are customizable. So the size of it can be, a 700 square foot facility up to, hundreds of thousands of square foot. The bins can be customizable. The racking can be customizable. What we do is just kind of pick and choose what best robotics are used for the use case and then design the system for the customer. Another really cool thing that we love to work on are having these systems be mobile. So every video you saw, those are actually all mobile systems that we can move to and from our warehouse to a customer's site. Built on top of a trailer, inside of shipping containers. This is actually one thing we're really excited about for the defense sector, for expeditionary forces being able to kind of ship out these whole systems, open them up and have them running right away. So that's something that we're really excited about pushing. But having this mobile capability is something that customers really like to have. What else we're working on with actually a major defense contractor is autonomous drone assembly. So using the same kind of robots you saw in the video, we can actually build basically an assembly line using 6-axis arms to assemble pieces onto the drone, and then using those AGV robots to be able to kit together parts, tools to be brought to certain areas where you do need that human aspect to do assembly. But this is something that we've been pushing really hard lately and working with a major defense contractor on developing. I won't go through all of these, but I will give an example. So our phase 2 SBIR that we're submitting for Joint Base Charleston, the idea of working with their Spark Cell, basically to be able to automate their warehousing facility where they're storing parts and tools. So when a plane's coming back, needs some repairs, needs updated, we can actually have the request put in of what parts are needed, what tools are needed. The robots would kit all of those together and then have that be brought out to the flight line so the mechanic can just have everything there ready. The accuracy of the picking and kitting is 99%. So you don't have that mistake of having the wrong tool, wrong part out of the flight line and have to go all the way back into the warehouse. So this is what we're doing for Joint Base Charleston. On civilian applications, 2 big ones for us right now are like large bakeries or snack companies that get orders from a convenience store, and they can have those orders pre-kitted instead of having to have pallets of product in the back of a truck, manually pick it depending on what the customer needs. We can have all of that ready. Pharmaceutical also is really excited about the mobile applications. If there's certain areas of the country where there's, a spike in flu, they could have these mobile warehouses brought out to that area, chilled, medication in there, pumping out to help the pharmacies. And then once that flu season's over, that can be then shipped out to another location where they're having another outbreak or, peak in sickness. So why we're looking for investment, again, based off of this whole seminar we're doing now, the automation industry definitely hasn't seen its big boom yet. So it's definitely a good time to get in on the automation market. We have a lot of history in this space, and then with our patented portfolio of systems and software, we're really excited about getting out into the market more. On the defense side, why sponsor? Again, I think really when you're looking at those expeditionary forces and not having a lot of parts and tools and materials at these kind of remote airfields, maybe in the east, having the ability to ship out these little warehouses and have them up and running within a day, I think is going to be very helpful. So we're really excited to kind of find some more opportunities outside of Joint Base Charleston. And that's all I have. Thank you, everybody.
Absolutely. Thank you so much, Matt. It looks like we already have, a hand raised. Quickly, not to rain on anyone's parade. Quickly before we get there, Murray, I don't think I ever asked you to introduce yourself. If you want to go ahead really quick right now. All right, we'll swing back around. Anthony, go right ahead.
Yes. Hey, Matt, that was a great 5 minutes there. A couple questions. You talked about shipping containers. Where do you source your shipping containers from?
We have a company. I don't know the name of it. I'm not the procurement person who does it. I think they're out of Alabama.
Okay.
Builds them, yeah.
Okay, because we have a. Go ahead.
Oh, sorry. I was just going to say we're not kind of stuck with one supplier. Again, we can kind of pick and choose. So if you have,
okay,
yeah.
We have actually a builder up here right next to us. They build shipping containers. The company is DGS. I'd be more than happy to introduce you at some point if you're interested in looking at other options closer to the Northeast.
Absolutely. Thank you so much.
Let's make that a note. And then my question is, you developed the software for these robots, you said?
So it's kind of the brain that ties the system from the robots software to the end customers, maybe warehouse management system, ERP.
Mm-hmm.
So it's kind of the middleware, if you will, that kind of has all the systems talking together.
Okay, just thinking about cyber assurance, securing your system so adversaries can't get into your system and mess around with you. Have you looked into that or thought about that at all?
We actually have. So especially with Joint Base Charleston, what we've figured out, and I'm not the kind of technical software person, was a kind of a one-way line of communication where their software would send requests to us, but we wouldn't be speaking to their software at all. And they were comfortable enough with that to use that in the process.
Okay.
Yeah.
Awesome. Thank you very much.
Yeah, thank you.
All right, next up we have Tim. Tim, I don't think you introduced yourself yet. So if you want to introduce yourself, you can.
Yeah, sure. Very happy to. Tim Denning, principal with Ultratech Capital Partners. We're early stage deep tech dual use VC here in the US, just outside of DC. But I'm also a naval supply officer, expeditionary supply and air supply as a reservist. So that's kind of my question is what is the capability to support forward areas and or OCONUS work, so like outside the United States? Over.
Mm-hmm. Yeah. So again, with the shipping container concept, that's really what we thought would be really a good opportunity for expeditionary forces to kind of have this little warehouse ready to go and built in a rugged container. We actually did test it out. The robots work great in it. When it's being kind of moved and shipped around, we don't have to really too much about the robots breaking if you just kind of strap them down. But these systems also, given they're so modular and flexible, they're really easy to have set up quickly. For instance, the one you've seen this video here, We had this at a trade show in Atlanta, and we're able to set it up in 2 days. So the ability to kind of have everything almost assembled already when it's shipped to be installed makes it very quick. So if you're looking for, rapid deployment somewhere overseas, we kind of just ship the parts, and in a day or two, these systems could be running. Hope that answers your question.
Yeah, no, certainly I would like to talk a little bit more, but also curious about the training. How difficult is this to operate? How much training is required? Could like a typical logistics specialist, like a typical LS5 or LS2, for instance, could they operate this?
Absolutely. So we actually design training courses that you can just have on like kind of computer courses that you can share. But as an example, we had a warehouse manager who his job basically was, take deliveries, whatever. He actually learned how to do this in about a month. It's very easy to run.
Great, thank you.
Thanks.
Perfect. We have time for one more question, one or two more questions. It looks like there's one. While we give folks time to think of one potentially. I think there's one in the chat. So maybe not necessarily. Looks like someone's asking about drone assembly and munitions, but I'm not sure if it's Sarah. Go right ahead.
Okay, sure. Thanks. Yeah. You mentioned expeditionary, applications. What about, power management then for these systems if they're being sent on a shipping truck out? Are they how will they be recharged, and how long do they last if they're not near any sort of charging system?
Yeah, so we have had these run on basically generators, and they've run fine. They don't take too much power, actually. The robots themselves, they have about I think 9-hour battery life before they need to be recharged. So if you're running, for something this small, 2 robots, you can pretty much get it going 24/7 if one's charging while the other is doing its job. We also have been working with this company that does these kind of these pads you put on the floor, and when the robot drives over them, it shoots up a jolt of energy to basically charge it as it's moving. So that also we've found allows you to kind of only have to use maybe one robot in some instances, given the fact that it's like continuously charging as it's running through its path. But yeah, to answer your question, we've had run this on actually a solar drone too. I mean, sorry, not a solar drone, solar generator, and have been able to have it run pretty continuously.
Cool. Perfect. I think that's all the questions we have time for. Thank you so much for the presentation, Matt.
Appreciate
it was a pleasure watching it. And yeah, feel free to leave your contact information. I'm going to be that broken record. Contact information in the chat. With that, the floor goes to Xena Drone. If Xena Drone wants to speak in sharing and presenting, feel free. Feel free to get going.
All right, awesome. Can you guys see my screen?
Yep.
Awesome. Well, my name is Phil Franklin. I'm the Vice President of Business Development for North and South America for Xena Drone, as well as Xena Tech Inc. Our company has, over the past 6 years, added the element of drone manufacturing to our business profile. We're actually a software development company with over 30 years of experience in multiple platforms and within different agencies and in different critical infrastructure industries. We started developing the Xena Drone 1000 back in 2019 in Chicago. The development process was established by very early with very inexperienced people, including myself. We went to discover the necessary means of building a drone, and from there, in a very quick time, moved to full-scale production with locations in 10 different countries. Our primary manufacturing facility in the UAE, expanding now to over 30,000 square feet. And we actually, at this stage, have 3 in production drones, as well as additional prototypes that we're developing for different sectors. We have in the past pursued government projects, having worked with the Navy, and actually have participated in Travis Park up in California. So it's good to see some of the folks there represented on this call. They at that time provided a lot of valuable insights to us as a company as we proceeded to do other things and expand in different ways as a company. But specifically around the drone itself, it is a Group 2 drone weighing 265 pounds with a full lift capability of 80 pounds and able to traverse up to 60 miles at a rate of 60 miles per hour. This is our primary and flagship drone. Some of the things that we are looking at using the drone primarily for within DoD would be around logistics support. So we actually have inside of the drone up to 40 liters, can carry up to 40 liters of blood, for example, when we're thinking about transportation of blood and other essential needs in the field. This is one of the most significant elements of our drone and its capability. We can carry both internally in a cooled chamber that can protect the cargo as well as underneath for different types of payloads if necessary. So just kind of looking at some of and this was geared initially for the U.S. Air Force. So I'll kind of stay within the context of what this particular capability is, and I can certainly discuss some of our other capabilities. But around the Zenodrone 1000, it's high altitude parachute drops, landing accuracy. These are some of the issues that are faced by some of the other drone development companies. And so we're exercising our full capability as a software and manufacturer of not only the drone itself, but all of the key components that go into its manufacturing that allow us to fast track any changes that might be required by our end users, be that DoD or in the commercial space. Existing drones typically carry small quantities. I'm sorry, carry small loads. Typically under 50 pounds would be most maximum payloads. Again, we can exceed that, reaching 80 pounds with other platforms in the future, looking to explore up to 1,500 pounds. In terms of viability, again, our internal chamber allows us to maintain controlled temperature for transportation of whatever elements need to be moved from point A to point B or A to B to C. Current drones, we understand, are not typically modular for military use. So usually drones that are introduced into the sector are designed for one way. Obviously, these particular drones, we can call them kamikaze drones if we want, are very useful in tactical situations, but for long-term use of a drone, the idea is that you want to be able to recover your cargo and commit to one particular drone for multiple uses. And that's kind of our idea going into the sector. We want to create a drone that will allow ongoing use and support military functions. And then many solutions require infrastructure or personnel at the destination. Our solution is fully autonomous, and we are implementing a 9-stage dead reckoning program that would allow for the drone to refuse interrupted or interception. So that's one of the key highlights that we've been working on over the past year, making the drone more secure and essentially impenetrable from interception. Our drone is a octocopter, so we can actually operate with multiple engine loss. Up to 4. It does depend on which motors these are. But in the development of this drone, the idea, again, is long-term use, is stability, and its recoverability. So these are key elements in why we did design the drone in the way that we did. The model that you're looking at right now is actually our 11th prototype. We've moved on to a 15th version, which we're commercializing for the use in DoD as well as in agriculture. So we're developing spraying units to support commercial activity in agriculture. We've, in the past 10 months, actually acquired 10 land surveying companies throughout the U.S., Florida, Virginia, North Carolina, as well as in Oregon, and pursuing additional locations throughout the U.S. This is particularly around our desire to acquire the knowledge necessary to increase the level of precision and accuracy in our data capture. So we're working with professionals who have over 100 years of combined experience in land surveying to better understand the importance of acquiring accurate information while in the field, and leveraging this as we continue to build our drone solutions. I've mentioned the high capacity for the high carrying capacity and multiple means of actually transport. Precision delivery, we can land within 3 feet of a target. This is actually an understatement with the more recent accomplishments. We've been able to land the drone within 3 centimeters of the desired target. And this again is due to the contribution from the land surveying companies and professionals who we've onboarded in the last 10 months. With regards to flight time, I mentioned 60 miles per hour. We're actually ongoing testing in Turkey over the next several months. The capacity of the drone right now is not fully known simply because of our access to space to actually fully test the drone's capability. It is designed with aeronautics in mind, and we are expecting to at least double the flight time, while doubling the speed. Temperature control storage, as I mentioned in the past as well. Mission ready adaptability. So this is also something that's extremely important for us as a company, our ability to customize on the back end and manufacture on the front end. To deliver end user requirements. So as we go into exploratory conversations with different members of DoD, as well as in the commercial section, we're often able to provide a reliable scope and deliver on those requirements within 6 months to 1 year, depending on the scope and the project that's desired by our end users. Some of the other objectives we have been involved in are around perimeter surveillance. Again, when we look at our payload capacity, we can equip the drone with multiple different types of payloads from a data collection standpoint. Our drones are all standard equipped with LiDAR, multispectral sensors, and a variety of different sensors that are very important to our clients, as well as offering the potential for very important data capture while exercising activities in the field. So we can operate from the standpoint of blood and medical delivery or ammunition resupply, search and rescue, tactical logistic resupply, a modular multi-mission ready payloads. And then our contributions is, as it pertains to SBIR, we were awarded a phase 1 back in 2023. January 2023, which we've continued to exercise those relationships and build on the requirements of those involved in that SBIR.
30-second warning.
Sure. Just to kind of close things up, much of which I've covered just in advance of some of the slides. From a commercial standpoint, again, we're operating in multiple sectors. We're actually pursuing drone as a service as one of our primary objectives for 2026, which would allow quicker access to our resources. We understand that from a financial standpoint, it's not always available for funding. So we're putting our technology in the hands of our end users a lot quicker by offering services for both DoD as well as our commercial potential clients. And this might be familiar to some of the folks that are from Travis. We did spend a little bit of time up there, as I mentioned, a couple of years ago, and look very much forward to engaging with the folks up in Travis again if the opportunity presents itself. Thank you very much for your time, and I appreciate you all.
Absolutely. Thank you so much. Anthony, go right ahead.
Hey, Phil, great briefing. Quickly, have you done any third-party flight testing and software testing on your system?
Sure. So currently actually undergoing AUVSI certification for green UAS, and ultimately moving on to blue UAS. We had a few components that we needed to switch out that were still Chinese sourced. Sometimes they're pesky little parts that we didn't even know we had. So once those smaller parts are switched out, we'll undergo the remaining of the testing, which involves obviously the security testing and the penetration testing. We're also pursuing UL certification for some of our other platforms. We do have a indoor warehousing platform as well that can capture data while in GPS denied environments, flying around warehouses, so on and so forth.
Beautiful. Yeah, we have Orion is my endeavor up here. We do IoT testing, drone testing. It'd be nice to maybe link up and have a conversation. There might be some interest.
Absolutely. I look forward to it.
Thank you.
Absolutely. All right. There's a question in the Q&A. about asking what is your go-to market strategy to crack the defense target segment?
So we, we've engaged with Eagle Point Funding, obviously, to support us in our SBIR goals. Our main focus in DoD is logistics support, as well as perimeter and base security. And so, we're pursuing different means of doing that, particularly through SBIR, as well as some congressional activity in DC. Actually, we'll be in DC next month on the 27th. We'll be approaching the Hill and seeking out support that way as well. From a manufacturing standpoint, we're already at the stage where we can produce 20 produce 20 drones per month. And we're looking to scale that as our end users are seeking additional pilots. So I hope that answers your question.
And then there's another question. Do you have a tethered
Yes.
persistent or tethered remote option within your product roadmap?
Yes, so we already have the configurations in place for tethered options. They are for our smaller drones at this stage. We have been asked to do something up to 30,000 feet with a tether, but we haven't quite come up with a solution for that. But yes, the option has for tether is there for our smaller units. The 24-inch by 24-inch IQ Nano is the indoor warehouse and drone, and so that one doubles as a indoor surveillance tool that can be either used via tether or through automatic charging stations.
Perfect. I think we have time for one more question if anyone wants to ask. Otherwise, we could keep this show on the road. All right.
Someone mentioned having the 30K altitude solution. Please get in touch.
Oh, and Gopal, go right ahead. Just
No, I
ask
was
your
just wondering
question.
what's the price point of the drones, like ballpark price point that you're targeting?
Sure. So for drone as a service, we're offering solutions which are full packages, depending on the scenario, for as low as $60,000 a year. For purchasing of the drone, it will depend on the type of data collection that's necessary. The drone in that particular case is going to range anywhere between $50,000 and $150,000. Really just depends on the type of package that's necessary, the type of data that we need to collect for you. What security requirements are met or need to be met. So it will vary. We're very focused on being adaptable and meeting the need, be it specific or broad reaching.
And it's battery powered, right?
It is. It is powered by 4 lithium batteries.
Thanks.
Perfect. Awesome. Thank you so much, Phil. And
thank you.
Again, broken recording here, but feel free to leave contact information in the chat if you'd like. Next up, we're gonna have Jeff McChesney from Target Arm.
Hi, Asher. Can you hear me okay? Thanks.
Yep.
Yeah, let me just
loud and clear.
Hey, great. Thank you. Let me get over to the right screen. And let me know when you can see it in present mode.
Yep, now we can.
Okay, great. Thanks, everybody. I appreciate your time. I'll be very swift. At least I hope to be. Hi, I'm Jeff McChesney. I'm the CEO and founder of Target Arm. And we enable drones to launch and recover from moving vehicles, air, land, or sea, and even space. It sounds simple, but it solves one of the hardest problems in drone operations today. And that's especially at higher speeds. Picture this. Soldiers driving into a hostile territory, and today to use a drone, they need to stop and get out. That causes vulnerability, it's inefficient, and it obviously risks lives. Worst of all, it breaks the #1 rule of combat, which is to keep moving to stay alive. This is Raylar, our patented robotic arm and launch and recovery system. It works with any drone, any moving vehicle, up to 65 miles per hour and beyond, by the way, autonomously. No stopping, no pilot. Now let's watch Raylar in action. So here's Raylar at work. A drone launches, clean, fast, and hands-free from a moving vehicle. No stopping, no operator. On return, the arm tracks and adjusts in real time, catching the drone midair, smooth and secure. This is our clear competitive advantage, and we've done this reliably thousands of times. Now, for centuries, logistics, commercial and military, have had one problem. You had to stop to really do anything. You had to stop to unload, to reload, or whatever you're doing. But we completely remove that barrier, and we do it autonomously. Warfighters stay safer, and package delivery reduces last mile cost by up to 95%. And with the new executive orders opening up the US skies, our timing has never been better. With $2.7 million in seed capital, we've generated over $5.5 million in contracts and booked over $4 million in direct revenue. We have B2G traction with the Air Force, Space Force, and Army, and they're all non-dilutive. Our B2B traction includes Hyundai and Recon Rig, and in 2 weeks, GM Defense will feature Radar and showcase us on their ISV vehicle at the industry's biggest show in DC. Like SpaceX and Tesla, we seeded with government funding before pivoting to commercial. Our market is huge. Over 800,000 US vehicles, military and commercial, in just these two markets. And there are many more markets than these two. Each vehicle kit that we're going to end up installing costs $75,000, whether it's a purchased or on a lease. And we start with 2 kit sales this year, scaling to 216 by 2028 for a moderate $216 million in revenue. We're going to exceed that. That's the lower number that I'm planning on. And this is a sales force buildup plan, not a TAM type of approach to it. This excludes our new Army contract for drone magazines, which we're currently on a SBIR Phase 2, which is to add magazines to our radar device up to 20 drones capable to be carried at any one time. And they're recoverable and rechargeable and relaunchable. And this is our sales-driven plan, and it creates a long-term revenue growth opportunity for us. Our team is built to execute. I'm a former combat fighter pilot and commander, startup founder, and CEO of Ray Dalio's $12 billion family office. Ryan brings deep aerospace and production experience from Sikorsky and UPS, and we're backed by advisors with billion-dollar exits, wide DoD experience and expertise for that matter, and 3 accelerators with all of their networks. Our go-to-market plan is clear. Continue DoD direct sales, which we're currently doing, expand to first responders and through distributors, which we're heading towards this year, and then scale into automotive and package delivery via direct sales. Each step compounds growth while leveraging dual-use demand. We protect our investors with a defensible moat by being the only player with proven, patented tech ready to scale up. Our autonomy stack enables on-the-move drone ops, modular, scalable, and agnostic to both the vehicles and the drones. And with those US executive orders that I spoke about earlier, expanding the airspace, defense and logistics adoption is imminent. So just to finish off the presentation, let's look at a Northern Strike exercise we did last month called Northern Strike 2025 with Radar, Maestro, Turbofly, and Tracker, which are all of our products, all with the using of soldiers. So you've seen the problem, our patented solution, how efficient we are with capital. We validated with the US military and we're ready to scale into dual use markets. To seize that coming market expansion, we're seeking a $10 million Series A raise starting in the next month or so. So we're Target Arm and we launch recovered drones for moving vehicles autonomously. Thank you.
Absolutely. Thank you so much, Jeff. Opening up the floor for questions. And again, if you cannot raise your hand, feel free to just jump in. No need to wait on the sidelines. So feel free to get things started. I guess I'll ask the question while we're waiting for folks to warm up.
Sure.
Aside from, military, I know in the video you showed some military use cases and are there like law enforcement? You're looking into law enforcement use cases or like firefighting or
Absolutely. Yeah, the market that we are currently expanding into right now happens to be the first responders. So police, fire departments, humanitarian disaster relief, fire fighting in the California forest and that kind of stuff. The reason why we are not doing it is because the airspace has been held back for beyond visual line of sight in the United States. The executive orders that were promulgated a couple of months ago are now opening up that airspace. And by the end of this year, we're expecting that to actually widen. And what's happening is that many of those local, state, and governments that have those various forces that we're talking about are desperately seeking solutions, and we're expanding in that market. We've had one provider come to us and ask if we can put it on 10,000 vehicles in the last 3 weeks.
That's awesome. That's awesome. I'll give the floor to Anthony. Anthony, go ahead.
Yeah, Asher, you took my question, but that's okay. That's all right. My other one would be, and I'm sorry, Jeff, it was a little choppy and cut off. That's my network issue here. Did you mention, so this works with any type of drone, you're saying?
Yeah, so we're not a drone company, although we build our own drones for testing. And we designed it for being drone agnostic. By the way, it works for rotary and fixed wing. The biggest issue with fixed wing is where do you put them once you've captured them, and then how big can they be to fit down the street. So we are drone agnostic. We've designed it to be that way. But most people that are talking to us right now are saying, let's get going with our drones. And so we've already sold our drones with our first commercial purchase.
So how do you attach the platform for your system onto an existing drone? Is it simple to do?
The requirements for each drone is individual, so it has to be certified on Radar. But the certification includes two things: a number of sensors that are available to it to get our 1 millimeter accuracy that we use. If they're not, then we need to put additional sensors on that drone. And the other one is compute on board. We have all of our compute is a wraparound. It doesn't get into any of the internal controls that you currently have. It's like flying with sticks, except we actually put that through a computer. So much faster than a person can fly. So it's designed to go onto any drone, but the drone needs to have both the compute capability and sensor capability. Otherwise, we would supplement it. The drone sizes here are probably in the 1 to 2 pound range is probably the minimum, and then up from that.
Okay, thank you, Jeff.
Yeah. Who else?
There was someone who. Oh, Sarah, go ahead.
No, I don't think. Actually, we've engaged with them before. I don't know if you saw. Okay. Oh, another Sarah.
Yeah, another Sarah. Sorry about that. My bad. Someone asked.
Yeah,
are you
Sarah
looking
Jones from InQtel. Sorry, I don't know what's going on with the video today, but Sarah Jones from InQtel. I did have a couple questions about the compatibility with drones. So, is there a max size and weight for the drone that it can accommodate? And then the second question was, are there any limitations around the payload a drone can have to be able to still work with the system?
Well, first of all, great questions. And Sarah, hi, the other Sarah for BAE, because we are a subcontractor to BAE already with Fast Labs on the East Coast. The answer to your first question is that, and I got to try to remember what they are because I just talked myself out of it. From a payload perspective, we're not too worried about the payloads. We've got multiple capture devices that can handle that. We're actually designed, and we built this whole thing for package delivery. So the idea about boxes being underneath and the size of the boxes changing and the weights of those boxes are exactly what we planned on doing. But we've gone to the military because they've been putting the money on the table, and the airspace is not a factor for them while we've gone ahead into our development. And I'm sorry, I just lost the track of the second part of that question. Could you repeat that for me?
Size and weight, max size.
Size and weight. So yeah, so size and weight. The drone has to have a Bodicom capability of a compute on board, and it has to have be able to carry some sensors to get again, we come in with a 1 millimeter accuracy that the drone needs to be able to fly to, and drone UAV is synonymous in my terms. Again, about a 1 pound drone is probably going to carry all the stuff that you would need to execute with us. And then as you can go on up, we designed on an Air Force SBIR a 16-foot wingspan that we're doing off of a cargo airplane onto a UCAV or a CCA. We did that contract working on the airflow around a C-17. So 16 foot wide down to 12 inches wide to give you a spectrum of what we would envision fixed wing or rotary wing.
Great, thank you.
Perfect. Mike, you get the last question.
Yeah. All right, great, thanks. How big is the system, and do you plan on reducing the size to accommodate smaller vehicles?
Yeah, so right now the one that you saw in the display, that's a prototype. We can change the size to fit almost any vehicle. Right now it's about 4.5 feet long, and it's about 2 feet wide and less than a foot high. We put it on top of vehicles, on SUVs. We load it on the back of firemen's trucks. We load it on anything that moves. It takes about 3 minutes to strap it on anything, virtually anything, the current one we have. That one has a suggested size of an arm that we want to use. And if you want a heavier drone, you make it bigger. If you want a smaller drone, you can make it smaller. The key component to where we're going, though, is this magazine that we're building for the Army also applies to our package delivery capabilities for lining up the drones and the packages that go with it. I don't think we're probably going to get smaller than probably 8 inches for a drone, that you would actually have enough compute on board and sensors on board to get there. For example, the Teal drones and the Skydio drones of the world as SRS or SRR birds for the Army, those are like 22 inches, 24 inches tip to tip. Does that answer your question, Mike? I want to make sure I did.
Yeah, you did. Thank you.
Okay, yeah.
Perfect. Awesome. Jeff, thank you so much for the presentation.
Thank you, everybody.
Yeah, absolutely. It's been a pleasure having you. One quick thing that I am just gonna quickly, if I could find it, announce is that we have one other panelist here whose mic isn't working, but Murray Chapman is a U.S. Air Force civilian interested in all aspects of unmanned systems, precision strike, and counter unmanned systems. So just so everyone knows, he's on the call, and he might be asking questions in the chat as well. So pleasure to have you. Next up, we are going to have Cognicy. Cognicy, go right ahead whenever you're ready to start with your presentation.
Awesome. Yeah, thanks, Asher. Let me share here my screen. I trust you guys can see it.
Yep.
Awesome. Yeah, thanks so much. Thanks for the opportunity to talk to you as well. What we are going to discuss here and what our company is working on is a more fundamental technology. Everything you've seen and everything that has any interaction between real world and the digital world, any kind of localization and mapping, they need to have some sense of space. Spatial awareness is very important. And that's why we are working on this new 3D perception system with our technology. And then if you look at the, just getting back to what this technology is applied to, anything that moves, everything, robotic systems, autonomous systems like cars, that could be for autonomous cars, for ADAS, but also UAVs, UGVs, robotics that moves around, so the physical AI, this explosion in the physical AI, but also the interface between digital world and the real world, like the mixed realities and the next generation of mobile. All of them have to sense the world in a way, and typically they do that in a 3D imaging. So the 3D imaging demand is actually exploding now with this higher demand, but also the current solutions are very, very limited. And they are limited because we can look into the different technologies, and the most straightforward technology that people are used to for ADAS, for example, is a LiDAR technology. They are very good. They can reach very, very long ranges with very low optical power, but they're typically very bulky, unreliable, very expensive as well. For robotaxis, maybe working, but for most of the applications, cost is prohibited, and usually also size limits the design of that system. Technologies like stereoscopic vision, which is the most common 3D depth sensing technology, they're often used since the invention of computer vision, but they're very, very dependent on the scene and they typically generate very, very low quality data, which means that you have to use multiple of those devices, reduce reliability as well, and also design gets compromised. And then you can see the new consumer grade LiDAR technologies that can be very small, but they are typically provide only low resolution and limited applications, also reduce where the use case that can be applied to. So really there's not a solution that can fit into all those requirements, high resolution, long range, high spatial resolution as well. So really what we need is a faster, cheaper, and better system that can do that. And that's what we are working on. So we're basically miniaturizing a LiDAR technology onto the sensor. So no moving parts, no expensive or unreliable components. Basically, it's just a sensor that has, CMOS sensor, like an image sensor as well, paired with a 2D array laser technology. And what is really unique about our device is that we are innovating on the pixel architecture. Just what happened with the 2D imagers, with the PIN photodiode, with all the information being contained within the pixel, which allowed, which allowed the resolutions of image sensors to be from very small resolutions to very, very large. That's what we are working on as well. LiDAR technology is very complicated. We have to timestamp in a very, very fast manner, allocate those photons very, very quickly. So this is really inexistent in the world today, and that's what we've been working on quite hard on. And basically, this technology allows us to operate the whole system as a global shutter, which means that reduced motion blur. So if you have those devices mounted on head mount devices, for example, with a high angular speed, you can reduce the motion blur by using a global shutter. The device itself is very, very compact, and you can see on a fingerprint, it's very, very tiny. We are using metal lenses to reduce the Z height, so we really can deploy that in many, many applications. Because of the laser, or the sensor is paired with a laser array, which operates more like a display, we operate the system in a software-defined fashion, basically bringing more of that intelligence, that autonomy onto the sensor, onto the system, so we can perform flexible regions of interest, object tracking, classification, all within the device itself, and also controlling the optical power, which is essential to be able to reduce overall power consumption, to maintain the module very small for thermal management concerns. And all that is all governed by the extreme edge computing that we integrate on the sensor itself. That is very important for signal processing and control, but also you can think about data privacy as well. Bringing that signal processing onto the sensor allow you to not output raw data that can be intercepted. So privacy is a concern as well. The market is exploding, is growing very, very quickly. We are initially targeting the industrial applications because it's easier. So robotics, warehouse devices that are they are just systems that integrate that. So all the applications that we saw before, drones, the arm, everything that can be just using that device, that's our first target. But eventually our device or our technology is scalable across all those segments, meaning that we, through design-ins, specifications, design-in of our technology, we can tackle all the segments as well. Our team is very experienced. I have a PhD in this field for 10 years ago. I used to lead the depth architecture team at Meta. My co-founder is a successful entrepreneur. He was a former VP of R&D at Lumentum, the laser company here in the US. Our advisors are also former VPs of Meta, GoPro. Ingrid used to work at Lockheed Martin as well, some folks from Lockheed Martin. And our goal for this year is to scale our team to really deliver our first product soon. And basically, the market is very significant. It's a dual application. We are targeting contracting the SBIRs with the Air Force and the DoD, but also to enable that technology, we need to look at the scale, really mass production, and mobile and automotive is a key. We have several patents on our technology. We really enable this new technology for performance and autonomy. And basically, we are getting a very good traction with our OEMs. We are discussing with automotive, mobile phones as well, mobile companies, and partners at Sony and TSMC as well, the leading image sensing partners as well. And we are currently raising our seed fund and looking for partnerships as well, both to enable the development and further development of our technology, but also to look at the long-term relationship as well within the defense department, but also in the consumer and the dual use. And that's it. And we are Cognicy. I'm open to any questions you may have.
Sure. Thank you so much, Augusto. Yeah, opening the floor for questions. I know that there are a few people who mentioned sensors and autonomy when they introduced themselves, so
right.
I would expect a few good questions. So opening the floor up to all those folks.
Hey, I got to go for another call now, but I'll follow up later. Thanks, Asher, for inviting.
Sure, absolutely.
Thank
Pleasure
you.
to have you. While we're waiting for, sure. Did someone want to speak?
Question. How much is the power consumption for this?
So it depends on the resolution and range. So our highest resolution, what we are targeting right now, it's at the VGA and all the way to 40 meters. And this is 0.5 watt of power consumption.
Okay, and you also mentioned it's AI based at the edge computing.
Mm-hmm.
Does that mean that we could have it send some threats and so forth?
Can you repeat? I didn't get it.
Since you mentioned AI-based edge computing, can I elaborate on that one?
Oh, absolutely, yeah. So the data that comes out of the sensor is already very highly compact quality data. So it comes, you actually have to timestamp all the photons that comes onto the sensor, organize them. So the processing of that data has to happen on the sensor, right? So we have to reduce the data rate, otherwise it will be very, very high data rate. So that edge computing, basically this AI, we can, on the process of reading out to the sensor, process the raw data directly, row by row. So we can perform, first, the most basic is depth extraction and point cloud extraction, but we can also provide, because the sensor outputs not only depth, but images, it's just another imager as well. We can do CNNs, and we have a CNN structure for optical flow, for segmentation, for object tracking, all that within the device itself. The technology that we are using is a more advanced technology to be able to do that. So it's a FinFET technology, 12 nanometer. So we can extract a lot of more compute from the silicon. But we are not aiming to completely replace a neural network or an AI-based signal processing, because that may take a very, very large computational power. But what we are aiming here is to get the low-hanging fruits and do parts of that pipeline within the device itself. And then, for example, for privacy, if you were to implement this into a robot, for example, or a monitoring for in-cabin monitor for automotive, you can just extract features from that image. You don't have to output the raw data. Typically, what the host or the CPU would do would get the raw data and process that raw data to give you actions in the end. What we can do is do that processing within the sensor and output only the features, so the further processing do the actions eventually.
Thank you.
Mm-hmm.
Perfect. Augusto, it looks like that's all the time we have, but it does look like some folks in the chat are quite interested in what you're working on. So if you want to leave your contact information there, feel free.
Absolutely. Yeah. Thank you so much. Yeah. Thank you all. Yeah.
Perfect. Yeah. And with that finishes up session 1. And for all the folks who are here from session 1, just so you know, you can continue to stay on if you so choose. The more the merrier. It's happy to have the panelists stay. If you have other engagements, that's also totally fine. And to those who are joining now, we really appreciate you joining. Unfortunately, which is at this point it's kind of a tradition almost, but we are running a little late, so we are going to skip the formal introduction. However, when you ask a question, if you could quickly introduce yourself the first time you ask a question, that'd be great. And that way, folks could it might even give it even more context and insight to the question while folks are answering them. So happy to thank you to all the panelists who have joined us for session 1. If you'd like to stay on, feel free. And to all the folks joining us for session 2, welcome. Excited to have you. And we're going to jump right into the presentations now. So really excited to see that. We're going to get started with RightNet.
Thank you. Let me share. Can you see my screen?
Got on mute. Yes, but not on presentation mode yet.
All right, let me change it. Slideshow. Can you see now?
Yep.
Yes, my name is Annamalai. I'm the president and CEO of RightNet Corporation. We've been doing business with DoD and various government agencies for the past 20 plus years. We have good experience dealing with the government on the defense related matter. So now what we've done is taking our experience working with the government and the DoD, moved it into an autonomous product, what we call as the Centris, which is swarm-enabled, networked, tactical relay intelligence system. I know it's a whole lot of mouthful. Let me say what that is. It is a product that is swarm-enabled. It is networked based on mesh networking and resilient and reliable communication. It is a UGV based. It has threat detection. It has threat mitigation strategies as well. And it's AI based. It is used mostly for wherever you see where the communication or where there is a contested or congested place where you need an autonomous solution. This is where we'll be. It is based on open architecture. We have published APIs, and it's based on SOSA architecture also, and it's plug and play, and it's easy to deploy. If you can see that, this is a simple diagram of how you will deploy that. This is Swarmboard, which has all the threat detection sensors, like the LiDAR, RF, and also the communication platform, where you could use multimodal communication like LTE, RF, and satellite. Even on the satellite, you could use LEO, MEO, GEO. And when I say we can use the satellite, it has the satellite link optimization also. So it is very smart in how to handle the communication part of it. If you look at the existing UGVs, they are mostly based on RF, and it could be compromised. In that case, then the UGV autonomous capabilities could be hindered. We also built this relay bots to extend the RF capabilities. So you could build a whole mesh network however big you want it. If you look at the OV1, it is, as you can see, it can detect the drone of swarm drones, a missile launch, or a perimeter breach, and it can communicate to the ops center. And when you think that the communications could be compromised, but then if you look at the technology that it has LTE, RF, and satellite communication. So when one of the nodes is broken in the mesh network, it can be taken out from the command center or it moves out of it. The swarm is self-healing and self-managing it through AI. If you look at the swarm, the Centris product has multiple AI agents. One side of the AI agent is managing the UGV movement. The other AI agents are writing on the sensors itself. That's one of the reasons why I'd asked a lot of the questions on the LiDAR from the previous presenter that we could use on this one. Then we have an orchestration layer that manages the swarm and the sensors and also coordinates with other Centris products. This is how the typical Centris looks. So you have the antenna, the LTE, the mesh, the sensor, and the AI engine. How do we detect threat? I'll give you some examples. RF interference, right? Detected. Hold on a second. When you see any detection, the drop on the SNR RSSI, then it knows there's a RF interference. And also, when there's a seismic activity that we sense, then we know it could be a missile launch. And when we have LiDAR or GPS drift, then we know there's a perimeter breach. Hold on a second, for some reason, this is, all right. What is so unique about our product? Most of the products that you see today on the communication side, it's geared only for communication purposes. And even the communication tools that you have, it's either geared towards RF or LTE or cellular or satellite. It doesn't have all the combinations and the AI to route your traffic smartly. That's part of the advantages for us. And the UGV, if you look at the standard UGVs, they are basically relying on the RF communication part. It doesn't have, when the RF is compromised, it becomes hard to control that or self-control itself. And you have threat detection mechanism, but it's all siloed. There's no integrated product for you to simplify the management part of it and also to put a cost limit. And since we have integrated all of this together as a single product, it's easier to embed a lot of the AI technology into it so that as things move, you can always train the model to become even more smarter. And
30-second warning.
Thank you. As you can see, since we work with the government and the municipalities and so forth, we have taken so much care for the security part of it. And also, it's weather proofed to IP8067, sorry. And we have published open APIs, and it's easier to integrate with your existing BMS or battle management systems and so forth. Thank you.
Awesome. Thank you so much, Anamale.
Thank
Feel
you.
free to open the floor for those who are just joining. If you'd like to ask a question, ideally, if you could find the React button and under the React button, use the hand raise, that'd be great. If not, feel free to just pipe in and we'll get to the questions in the order hopefully asked. So feel free to opening the floor now for that. But while we're kind of waiting for that to start, I mean, could you tell us about some of the government traction or government projects, if you're
No,
allowed?
that's a good question. Even for this UGV, we had a meeting with the one of the generals in the armed forces. He was very impressed and interested in it. So they have called us for the follow-on meeting to the Pentagon. So we have a meeting scheduled for October 6th to discuss even further.
Oh, that's awesome.
Yeah.
We have time for one or two more questions.
Any other questions from anyone?
Yeah. And then can you tell us about some other use cases that there may be, or some use cases you didn't cover or that you thought
Yes.
about?
There are use cases that I didn't cover because of the timing. A lot of the commercial side of things is when where there's like a fire location, wherever you want to do a reconnaissance or when you want recovery, that you could send this robot, the UGV, with all the sensors in it, it can self-navigate and go recover. Public safety. Those are the things that we stress.
That's awesome. That's awesome. Thank you so much, Annamalai.
Thank you.
Oh, Marissa, go right ahead. You're muted. I don't think we can hear you.
Is this hardware or software or hardware and software?
It's hardware and
it's-
software. It's a
And then if
combination.
it's swarm, it means that you have several robots working together, right?
Yes.
Okay.
It has the technology and the capability to work together. And one of them is compromised. It knows something has gone wrong with one of the nodes, then it can self-form itself.
Oh, wow. Okay. Thank
So
you.
what happens is today, a lot of the technology, when it comes to communication, right? They use a single model, or then you need to have too many hardware to combine to bring in a resilient and a robust communication technology. So this one brings all of them under one roof with the AI built in. So it knows smartly to know where to and how to route the traffic. When the RF is broken, it will use the LT or the cellular, or even both of them are compromised, then it could use the satellite. Even on the satellite cost-based routing, we have it so that it could use LEO, GEO, MEO. So
Perfect. And then, sorry. One last question that looks like from Sarah Jones. Sarah, you want to go right ahead?
Yeah, hi, Sarah Jones from InQtel. So I wanted to understand where are you in terms of TRL? Do you have a physical prototype, or has this been mostly from a modeling and sim standpoint? Would love to hear.
No, we have the communication, the sensor models ready to go, but we are working with, since we are a small company, we don't have our own proprietary UGV. So we are in discussions with the UGV companies, a couple of them. And once that's completed, then we will have the integration, the AI orchestration layer installed on it and tested. That's where we are.
And then one last question. Do you have on your roadmap dealing with GPS denied environments?
Yes.
Great.
Perfect.
So we have a meeting with the NATO in Brussels to discuss some of those challenges and how we can help them.
Awesome. Thank you so much for the presentation. Feel free to leave your contact information in the chat.
Yeah.
Next up, we have Skyfish. Feel free to start sharing whenever you're ready.
Let's see here. Can you all hear me okay?
We can hear you. It's not on presentation mode. I don't know if you can change that or if that's just the way it's set up. If it is, that's fine also. Oh yeah, I don't know if you can full screen it.
Okay, let me try it again. Application window. Is that full screen or not?
Yeah, it's good enough.
Okay, I apologize. I'm not quite sure why it's doing that. Okay, well, I'm Morris Pilscown, CEO and co-founder of Skyfish. Thanks for having me today. Skyfish is a full stack drone manufacturer. We've been in business since 2014. That means we've been building drones commercially in what's somewhat a hostile environment for several years. DJI was an 800-pound gorilla, and we had to figure out how to survive. And the way we did that is we built out the entire stack, but we were focused primarily on accuracy and 3D modeling. We wanted to make the best 3D models in the industry. But in order to do that, we had to build out every aspect of the drone. Didn't mean we made our own radios, but we only chose radios that we could control the firmware and the integration, same with whatever chipsets we did. So we built out an entire drone system based around accuracy and focused on the engineering market. And as you can see here, we not only built out the drone, but the controller. That is not a controller that's just a tablet stuck inside of a case. It's actually an entire motherboard with all of the supporting hardware. So it's kind of rare to find a small drone company, we're slightly less than 50 people, that has been building all aspects of their drone for the last 10 years. It gives us a lot of expertise. And I have some stories around people who, found us and were surprised that we're a nimble, small company that's in the drone business. So we're DoD ready. We're just going through that green list, blue list process. We're actually on the last phase. We have a trusted supply chain. Everything's NDAA compliant. That engineering grade accuracy is critical for a lot of different use cases, but we're also working in GPS denied environments as well, because a lot of the engineering use cases, you need to fly under bridges, or, in the cell industry, you're basically getting bombarded by a lot of electromagnetic interference, and you have to be able to operate in that environment. So what I'm getting at is, although we're an engineering based company, I think we could quickly pivot into some other use cases. We actually have a case study in that, a real world case study. About 3 years ago, we were approached by DHS, and they said, "Hey, we're replacing an entire subsystem or subset of systems that we think that you'd be a good match. Can you come out in the next 6 weeks? I know it's short notice, but can you integrate the sensor and show us some of these things like increased redundancy and, tight integration with this payload and a customized C2 link?" And we said, well, we'll give it our best shot. So we came out and we were up against 10 other companies. A lot of the big companies like the Lockheed Martins and the Boeings were in competition there. And we won it. We won the initial order. And not only that, we won the 2 follow-on orders for fleets. So it showed that we could go from an engineering use case to an ISR use case with little notice, and being also able to scale as well. And so kind of my message here today is, we're small, we're nimble. We've been working in the drone business for the last 10 years, building out all of the subsystems, and we can easily move into these other areas. And we actually have some initial traction. I can't talk about some of the stuff that we're being approached with, but I think when you look at the competitive landscape, Skyfish fits into a special area, right? So we're looking to collaborate with DoD. We don't have a lot of traction yet there, but we have a lot of traction on the engineering side. And if you look at any of like the SBIRs, which we're starting to apply for, they always go, "Hey, can you be successful in something else than defense?" And that's Skyfish. We're already successful in something else, but we do want to move into this area. So the SOAR report did mention us as a key player in this industry. And what I'll say is that if you want to get involved in any of these types of activities like infrastructure inspection, ISR, public safety, delivery, you have to have these subsystems, right? And so we have all of it: the remote control, the edge of network, the flight control, the navigation and planning, battery management, some power plant, machine vision. Matter of fact, we have an AI model we created on the back end that is unique in that we're doing 3D analysis by leveraging 2D AI models, and it's patent pending. So we're doing a lot of really interesting work that's not just, oh, you're a hardware company and doing drones. We're actually doing AI on the back end and AI on the front end. So for a small company, we're doing a lot and we're being successful at it. But really what this is about here today is we would love to get involved with a DoD partner on some new contracts, expand our horizons. And we've got an amazing team. I said a little bit, about from Montana, but my background is math, physics, went to school at Washington State University, worked for Lockheed Martin. And if you want to read more about me, there's some little blurbs. But we have really an amazing team. A lot of folks that were previously in DoD helping out with Skyfish. So anyway, that's my pitch today, is to say, hey, we're a full stack drone vendor, and we're willing to work on projects that, you know, a lot of other people might not be willing to work on, or they're not nimble enough to work on it in a fashion that's quick and cost effective. So that's what I got.
Absolutely. Thank you so much. Opening the floor for Q&A. Feel free to either raise your hand or blurt out whenever you're ready to ask a question if someone wants to go first. I guess I'll go while we're waiting. In terms of the DoD partner, I mean, what have you seen? And if you're allowed to answer this, what would be, you know, kind of the main projects or use cases you've seen the biggest, you know, kind of
The easiest crossover, obviously, is Army Corps of Engineers, and they're using our system. There are some that have been approaching because they're interested in the whole DHS use case that I talked about. It shows that we could cross over into kind of that ISR area. And so that's something else that we're looking at, as other ISR type payloads. But I think the interesting thing that, you know, potentially we can do is that, since we own the whole stack, we can actually put this in you know, as we scale, and we do have some major backing now. As we scale, we can put this into this more of an attritable system. So think small, low-cost drones. You know, that's not our usual business model. We were in the higher end engineering type drones, but now we have that capability with some partners to create these small, low-cost, you know, attritable systems.
Sure. And so one question that's in the Q&A that I'll just ask now is, do you use any fiber for RF pathways?
No, but you know, we've been asked about various, like, can you integrate this? And we're like, sure. I mean, that's the beauty of owning the stack, is if there's a new piece of hardware or software, that's why we could pivot in under 6 weeks and win a competition. It's because we were able to integrate quickly. So if that is a requirement, you know, bring it on. We'd love to try it.
Yeah, and I think you already answered it, but the next question is basically if your technology solution is drop-in, or if you work on discrete engineering projects, or both, and it sounds like it's both, obviously. I mean,
yeah, it's both. I mean, we're selling quite a few drones just off the shelf into the engineering market. We've done some custom stuff for customers. We actually do some work where we actually work with partners in the field, flying for them until they adopt the system themselves. So you know, kind of all of the above.
Sure. Absolutely. I think we have time for one last question if anyone wants to ask. Otherwise, we'll keep things going. All right. Perfect. Orest, thank you so much for the presentation. Feel free to leave your contact information. Yeah, thank you for the presentation.
Yeah, thank you.
Absolutely. Next up, we have Dolphin Labs. Feel free to start screen sharing whenever you're ready.
Guys, give me a second here. Press some buttons. Okay. Oh, no. Fingers crossed. Is that coming through?
Not yet, but maybe that's just my internet. It says you've started sharing, but it hasn't. I don't
Yeah,
see
I
a
see
screen.
that. I see that as well. Okay, weird. Give me a second. Let's try something else. I'm getting a weird thing flashing my screen, which is never a good sign. Anyway.
Nope. If need be,
not, I wonder if one of the other.
We could probably share it on our end.
Oh no.
Nigel, I can share it here.
Oh, thanks, Riley. Would you mind?
No worries.
I'm gonna kill this.
There it is.
Riley to the rescue. Thank you, sir.
You're good.
Riley, can I get you to drive the slides as we go?
Sure, absolutely.
Chat. Okay, great. Well, hi everyone. Joined here by our illustrious CEO, Rolly Hogan, who's saving the day. But my name is Nigel Sharp, and I'm representing Dolphin Labs. We are working towards interconnecting the oceans by providing power and data to autonomous systems that we see becoming a critical element of sort of the future of autonomy in general. Next slide. One of sort of the driving pieces of this is like, what we're seeing in the news. Just one use case and one example is obviously the undersea cables that are being cut and being damaged all around the world, which is driving the need for more monitoring and security need and threat, along with just greater maritime domain awareness work that is happening all across different militaries around the world. Switch to next slide. So what we're seeing sort of broadly in this ecosystem is that there is a need, especially in the maritime domain awareness world, to, at the very base level, secure just critical infrastructure, maintain things like undersea cables and pipelines, etc., with an expanding sort of market need around sort of defense, energy, and environmental areas, of course. And that's really the sort of dual use component of this, as well as like just enable persistent operations. And this is really where it gets exciting, is that when you start talking about autonomous systems, like on earlier presentations today, where you need to recharge and deal with robots, we're in the business of providing the power and the data to allow for that. So kind of think of us as like Starlink and superchargers, but for underwater. We're creating underwater data and power networks with a global reach. We are connecting the seabed all the way up to satellites. So operating and getting that data from places that are very hard to transmit and engage in active communication, all the way up to places that need fast and engaging responses. And then most importantly, providing continuous power generation to allow for AUV charging, sensing operations, etc. Next slide. So our vision and where we sort of see the world going, as I'm sure is shared with many of us on the call, and if you are tracking some of sort of the Navy's priorities and defense priorities right now, is we see that as we move forward, autonomous swarms and coordinated underwater operations are becoming an increasingly demanding area of operation that the Navy is actively invested in, and beyond the Navy, also other arms of the military are actively engaged in, both for protecting critical infrastructure, port operations, military base infrastructure, etc., but also for like forward expeditionary work as well. There's a need for maintaining persistent operations, right? 24/7 support and operations in those areas. And these days, not having connected systems just simply doesn't work anymore. And so with battle management systems and other types of integrations that are needed in these sometimes GPS denied environments, etc., global connectivity is ever present and needed, as well as like strong data networks that can exist both above the water as well as below. So a little bit about us. We're Dolphin Labs. We have our HQ in Alameda, California. So I apologize for the accent, but it is very much a US firm. And we have been building in sort of the greater San Francisco Bay Area now as a spin out from Berkeley University and CalWave, which is very well known for their wave energy technologies, with a greater focus on dual use applications. We've got academic partnerships with the University of Washington, Oregon State University, etc. And maybe most notably for this particular group in this call, we'll highlight a few of the cluster collaborations we have, specifically the Pacific Northwest Defense Coalition's Mission Acceleration Center. We were awarded the only U.S. companies award for the NATO Diana Phase 2 award, so the NATO's Defense Innovation Award. We're actively engaged in multiple U.S. DoD contracts right now. And I can speak a little bit more about that in a second, as well as we're plugged into various blue economy and investment platforms to do that. We're a little bit further along than some of the companies that presented today, but we're still very active in trying to get more partnerships and potentially open up an investment around near the near future. Next slide. So really quickly, the history of the company is there was a live sea trial, 10-month sea trial, with a technology based on the sort of base technology generating power in the ocean that can be generated both on the surface as well as submerged. And I think like we talked, some of the earlier panelists were asking about what are the key differentiation. One of the key differentiators for Dolphin Labs is the ability to be able to charge and generate power while staying stealthy and submerged under the water. And that makes it a very unique technology. Sort of pictured on the right there, you'll see on our sort of brochure panel, the submerged picture of this. And with that, we have backing now from various DoD agencies, but specifically naval facilities. We've got an active contract with them. We're engaged and trying to engage with operational energy offices, as well as the Department of Energy. And then we have that backing from the NATO support as well. And we have our full-scale sort of deployment rapidly scaling up in 2026 with some of our early sea trials with our new X node system, which is sort of pictured there, launching out in Q1 of 2026. Next slide, Rolly. So our first demonstration of the X node system will be off of the Cal Poly Pier, and this will be a system that will be able to both provide power and recharge an AUV platform. We're partnering with some different organizations to look at doing that, as well as be able to generate communications power and be able to send stuff back up to either satellite or 5G offshore communication. And then as we sort of proceed into Q1 of 2026, we're actively going to be raising a seed round. It's a pretty exciting opportunity for those who want to get engaged. Thus far, we've been heavily backed by non-dilutive funding to the tune of about $4.2 million to date, with both phase 2 and phase 1 SBIRs and some other contracts. And we are actively sort of moving forward now to look like bringing out that sort of seed round. So for the investors on the call, happy to have that conversation as well as we start looking to open that up. And Riley's here as well. Yeah, next slide. So I'm going to leave it there, I think, and just to highlight that we believe that if you're going to build an autonomous future, and we start thinking about things globally, we all know the planet is covered in a huge amount of ocean, and ocean provides critical maritime infrastructure and shipping and coordinated logistics that are absolutely sort of imperative to our national security. And therefore, with that in mind, there is going to be a need to be able to power and connect all of those systems together. The X node is at the forefront of having a system deployable in the water that can easily power and support those systems in a stealthy and military capable way. And we're in an exciting sort of point to start partnering and growing that out. And I really want to emphasize the partnerships in this as well, that there was a number of companies presented today, everything from swarm robots to the ability to land and capture even air drones and charge them on platforms like ours. And we're very interested in looking at all those partnership opportunities and building out collaborative proposals as we develop out our platform system to provide that power and data to you all. So thank you. I'll pause there, take some questions.
Thank you, Nigel. I'll open the floor, but I have several personally.
Jump in.
Yeah, I'll jump in while we wait for folks to raise their hands. How does it work? Do you guys, in terms of the power, I understand that you have a docking system, but also, is there a way, like in terms of this, you had a picture of a satellite, like beaming with a satellite. Are you guys able to like send power? And if so, what are the safety concerns there, et cetera, et cetera?
Okay, so I'll speak to the graphics a little bit. So first of all, the beaming laser power off the platform, no, we're not looking at doing that. That was more of a graphical representation of connectivity connections. So no, we're not currently doing that. All of the power transfer we're currently looking at is using various sort of docking technologies. We're looking at partnerships with folks who work out of Scripps University, et cetera, who have docking technologies available for some of the various AUVs and UAV drones out there. As well as we've looked at some induction charging plates as well that that'd be supported on the seabed, so you could drive down and park AUVs, etc., onto those for charging, as well as just sort of like cables you can hook up for powering sensor arrays, etc. So no, most of the power is transferred that way. We have done some innovative stuff looking at transferring power over fiber optics, etc. So you can end up with very low signature power transfer, but that's sort of more of the advanced stuff that we're looking at right now. So that's a great question. And the second piece is, as far as how it generally works, I think like the picture here on the right kind of gives you a bit of an idea. And this is in a deep sea environment where you're using a counteracting heave plate to sort of pull against as the wave motion pulls against the underlying sort of sea waves. But in general, in the sort of more shallow waters, up to about 200 meters, we'll have a very simple anchor system. Just imagine like a few train wheels anchored to the seabed. And then we are able to sort of like counteract against that seabed and just using the counteractive force of the waves. The nice thing is the wave energy generation technology that CalWave really pioneered over the last 10 years can also still be applied in that sort of first sort of 10 meters or so of the water depth, and that allows for us to generate power in a submerged state as well, which is obviously very very applicable for a lot of these applications. So.
Sure. And then also that leads me to my next question while we're still waiting for folks. In terms of how far out, or is there a limit in terms of like the depth of the water that we're looking at here, or is it kind of you guys can make like a highway, from one area to another, just dotting these along the way so that drones or whatever could refuel?
Yeah, well, let me answer the question with a little bit of a business answer first. The business case of this is the majority of infrastructure that we're trying to sort of support and protect most of the time is land-based, and therefore the majority of what people want is they may want to create a fence or a net of systems that could power drones, etc., that might be 10, 15 miles offshore, in which case, generally the depths you're dealing with are often in that sort of sub 500 meter sort of range, those kind of nearby shoreline activities. But there's no reason why these can't be applied to deep sea applications as well. So again, pictured there on the slide right now is our deep sea version. This is in development. So this is not one that we're going to be having live. And this will be sort of closer to 2027, I think. And this will be using a counteracting heave plate where this could operate in deeper sea. So, 1,000, 2,000 meter depths, seems applicable.
Okay. Yeah, that's really neat. Yeah, I guess there is not much of a business use case necessarily to make a drone highway yet over water. But
it is fascinating that as we're seeing the advance in USVs, right? So unmanned surface vehicles, all of those are having the constant challenge of how do we refuel those? Where do they come back in? Where the ability to drop something like this out of the back of a helicopter, off the back of a boat, quickly deploy it with a single point, anchor into the water, and you're instantly connected, and you instantly have a power point, allows for in some of those again, expeditionary centers and frontline operations, allows for us to rapidly have that network available at a relatively low cost. And again, these are assets that don't need a whole lot of protection otherwise, and then being able to sort of drop drones down alongside them to work with that. And that's really where we're sort of excited, is that when you think about the X-Node systems, again, they are just your superchargers and your Starlink points that are connecting people up in the oceans, but it is allowing and enabling the 150,000 autonomous craft that the Navy is currently actively trying to contract out and get built right now. So
sure, absolutely. We have time for one more question if someone wants to ask. Okay, go right ahead, Marissa.
What's the limitation of the submerged power? I mean, why would you not have everything submerged?
So it's an interesting balancing act, Marissa, that practically speaking, from an energy density point of view, you can imagine that if you're just imagine you're sitting in on the waves of an ocean, like at the beach, right? When you're sitting in the beach, you can feel the waves as you're sort of sitting on the surface. But if you dive yourself underwater, you won't feel the motion of the waves as much. And so that practically is how wave energy is generated. So our background coming from Callaway and Berkeley University has been in that optimization of power dynamics, where you want to sit in that area of the water column that is maximizing. So in certain cases, if we're recharging batteries, we're trying to do that, there may be an opportunity to be at a surface operation, but there may be other moments where we want to be more covert. And for example, in storm surge is a good example, right? When there's a heavy big storm, a lot of the competitors can't operate in those really huge swells, where we can submerge the entire craft, bring it under the water, and put it safely there, while it can still be transmitting and providing power with onboard storage, etc. So in itself, the unit is really a bit like a drone. It is also smart. It's like a smart robot. It is going up and down the water column. It's figuring out how to maximize power, connectivity. But if you go too deep, you have challenges of how do you extend out the aerials and connect up to the satellites, etc. It's a lot easier to do that from the surface. So it's constantly trying to figure out how to balance it out. And you've got to think about these not as standalone units, but really in a mesh. We might have a mesh of 5, 10, 20 X nodes connected together, spanning tens of miles or 100 square miles, etc., that we want to sort of protect or navigate. So
awesome. Thank you so much, Nigel, for the presentation. Yeah, feel free to leave your contact info. This was really
I'll post it in the chat.
I really enjoyed this presentation. Thank you.
Great work, Nigel.
Yeah,
Yeah,
absolutely. All right, for the last presentation, we have Swarmbotics. Feel free to begin sharing whenever you're ready to go.
Hey, thanks, Asher. I'm going to pull it up right now.
Go for it. It's good to see you, Steve.
Yeah, you too. Can you let me know whether it's coming through?
Sure. I don't see anything yet.
Let's try it now. All
Yep.
right, I think we're good.
We can
Hey,
see
everyone. Yep, great to see everyone. Steve Potter here with Swarmbotics. We're building low-cost ground robots, primarily for defense first, but we feel like there's things like that. Let me see here. Okay. Company was started in late 2023. We're located in Phoenix, Arizona. You can see our team's grown from, foundation, founding team all the way to roughly 30 employees. We've had 2 sequential successful venture fundraises, a pre-seed round, and then a seed round. And we're positioning for a Series A as we go right now. We are actively in production of prototype units as well as selling units at this point to large primes for integration into different mission packages in different mission vignettes. So our flagship hardware product is called the Fire Ant, and you can see it here in the picture. There's a couple of them. It is a attritable UGV, meaning it's largely built off of low cost or commercial off-the-shelf parts. It is an absolute workhorse of a vehicle. As you can see, some of the specifications, roughly 80 pounds, can carry 1-to-1 payload to weight ratio, has a really strong durable range of 25 kilometers, active driving, which roughly specs out to about 6 to 8 hours if you're not running a significant payload draw. We have a LTE as well as a RF radio. So those are hot failover mechanisms. The robot finds the best mechanism to communicate and then essentially punches out its signal to the swarm. So as long as you have one vehicle with a strong signal, it will operate the swarm. And I'll talk about the swarm in a little bit later. We are fully autonomous. We don't use LiDAR, which is another benefit for ground robots. So we use 3D stereo cam. You can see a stereo camera on the front as well as 2 on the side. Significant offboard power through power over Ethernet for payload. And I'll talk about some of the payloads we've been doing. Really, this is a multi-mission UGV for different specific mission packages, right? Surveillance, whether that be visual surveillance, chem-bio, perimeter detection, kinetic engagements. It's really, again, sort of a general purpose mule for specific effectors, depending on the mission set. We're also building what we call our ground swarm orchestrator, which is called AntsNet. You can see the 2 different versions of AntsNet. The one on the right is actually driving at night, autonomous driving. And the left is what we call our web app, and you can see some of the features there. So you can hand off control of the robots via an ATAC device or back over to the web app. You can drive the vehicles, either a single vehicle, teleoperated. You can select multiple vehicles, send them on autonomous routes, and then you can also execute tactical swarm missions. So we're building, military-based swarm missions. So you think of like road march, defend, surround, attack, ambush. In those bespoke tactical plays, you select the robots. And then you select the swarm play that you want, and the robots execute the swarm mission, right? So it's really tremendous capability in the swarm mission, and it's really focused on specific mission sets. The one that we've gotten the most use out of is reconnaissance. decoy operation. So you can see some of the payload mission partners we've been partnering with. So large primes are buying these vehicles, integrating the mission packages, as I said. So General Dynamics, Northrop Grumman, L3 Harris, for different mission sets, right? Terrain shaping, which is like deep kinetic missions, general purpose payload integration, military deception, electronic. Chem bio detection, and then we've also done lethal attack with this robot as well in a training environment. So I wanted to talk through some of the concepts of employment. So this first one is what I would consider one of the strongest swarm plays we have. So let's say you have an expeditionary airfield or even a domestic airfield. These fire ants would be controlled either from a local operator, let's say you had a security forces officer or mobile patrol, or you had a command post. You can control them either way. You can set a patrol route on the perimeter of an airfield, and the robots would patrol autonomously with, chem bio detection, counter small UAS, ISR, right? You can put all three mission packages on the same robot, frankly, if you needed to, at a small form factor. So it just gives you tremendous operational capacity for these type of mission sets. Again, could be employed expeditionary, could be in a domestic scenario as well. On the ground side of things with the Army or Marine Corps, there's been quite a bit of thought process towards implementing small attritable robots all across the battlefield geometry, right? The flat forward line of troops, maybe you're at the line of departure, you've got of a light infantry vehicle or a mechanized vehicle, and the vehicles provide local protection, sensing of incoming threats, what we call formation-based layer protection. Then you move forward into offensive operations. You got operations with robotic breaching support, terrain shaping, and then if you look all the way to the right, you've got lethal attack capability. So you might put an energetic or some other side attack munition on the robot for terminal attack missions. We're seeing it in Ukraine all the time, whether it's a bunker or a combat vehicle. So that's kind of how we envision and how they're being used. And there are Army programs of record that are being generated for this class of robot right now within the Army. This vehicle is, this graphic is showing the vehicles in a recent SOCOM demo we did. So we had a small geofence perimeter in the SOCOM collaborative autonomy, and the vehicles were given the task to do what we call area reconnaissance. So there's no human intervention here. All the vehicles have a radiological detection payload. The geography here is it's a small piece of land here, but that could be 2 or 3 kilometers, as long as operate. Okay, so that completes my presentation. I'm going to move back to the front slide that has my contact information at the bottom. I'm happy to answer any questions anyone has.
Yeah, let's open up the floor for questions. I could get started if it's okay with everyone, unless someone had something someone had something already ready. I just wanted to know what kind of for offensive capabilities. I don't know if you can answer this, but what are you mounting usually to or what kind of payload are you able to mount on these?
So from an offensive standpoint, there's really 3 different offensive payloads. So we've used an electronic attack payload as part of a Navy exercise where we were defending a piece of land against an invading force, and we were trying to kill small UAS drone signals, essentially, using the fire ants as mobile EW attack emitters. We've also used working with like a EOD detachment within the U.S. Army. They built a 25-pound lethal attack payload, which we exploded under a vehicle, absolutely destroyed the vehicle. Unfortunately, the fire ant was also payload for like what I would call like local breaching of doors, or like think of like a built up area or a moat type scenario.
Hey,
Nice.
Steve, this is Annamalai from Brightner Corporation. I had presented about our capabilities, and I think your product will be an excellent choice for us since we are still sourcing for the UGVs to integrate with our product. I have a couple of questions about the power. What is the capacity for this? Is it lithium based, and how long can it run? And if we need to get power supply from the UGV, how many hours of power supply that we could get?
Yeah, I mean, that's a complex equation that requires some technical analysis. Would be happy to talk to you offline about that. I mean, we've got,
Yes.
you know, we build custom lithium ion battery packs. You know, to operate the UGV, we're looking at, you know, 6 to 8 hours at full power driving. So any payload draw off of the UGV would detract from the range of the vehicle, but
Right.
I have the specific specs I can send you.
Yes, I would love to chat with you after this.
Sure.
And
And
how
Bill,
big are these? How big are these UGVs?
Steve, were you able to hear that?
It cut out for a second, sorry.
Yeah, you were asked about the size of the UGVs. How big are they?
So I would, if I was to describe it with an example, it's roughly the size of a push mower deck. So if you're familiar with, like, you know, a lawnmower that you push, right? So that's about, give you a visual size, right? It's about 2 feet off the ground, so mid calf level at the highest level, 80 pounds with the full battery. And again, like I mentioned before in the briefing, an 80-pound or more payload to weight ratio.
How about the mobility? Can it roam around in the desert condition?
Yeah, we're in Phoenix, so we have operated it quite a bit in the desert. We've also operated it in the Midwest, up in northern Michigan. Does very, very good on soft sand, so it has strong mobility in soft sand. We've never done like Arctic conditions, so that would be an ODD that we haven't really worked in. It's got about an 8-inch step climb, so you think of like an 8-inch tall log that it might be in front of it. It's going to be able to traverse over that. It does have, it's in autonomous mode. You know, it may look at that log and say, okay, that's an obstacle I need to move around.
What is the IP rating for the weatherproof?
So it's IP54 right now, which we're moving towards IP68 in our next design rev.
Thank you. And I have dropped my email, so if you can, I'll send you an email as well to have further.
Awesome.
And Steve, there was another question in the chat. They wanted to know if the platform's reliant on GPS for PNT. What kind of PNT solutions are you guys using?
So it's not full, what I would call GPS denied right now. If you've executed a swarm or a autonomous route and you lose GPS, the vehicle will continue to the known point that it was provided. We are working on our product roadmap in Q1 2026 to add full GPS denied navigation on a robot.
Yeah, no, that's a good answer. And then, yeah, I think we covered most of the questions, unless there's one last question. I know we're over time, so there might not be, but if there's not, thank you so much for the presentation, Steve. I think we cut out again. I said thank you so much for the presentation, and be sure to share your contact information. And thank you for everyone who joined. Thank you for all the panelists and all the companies who presented and were able to ask questions and be engaged. We really appreciate it. Feel free to join us next month for the Space Showcase. And have a good rest of your day to everyone who's signed
Thank
in.
you.
Yep.
Thank you.
Have a good one.
Thanks, Ash.
Yep, absolutely. Bye, everyone.